All right, so I think I can mute everybody so that we'll have a smooth conversation. Okay, so before we get into today's, I want to talk about functions today because I think we're busy a lot of functions going ahead. But before I get into functions or how to define our own functions, let's look around with the function inbuilt functions in Python. Of course, you guys now know about the print function or the print statement. In Python 3, it was a statement. Okay, so a statement means it doesn't have parentheses. You can't call it. It's just a statement. For instance, if for is a for statement, okay, or for loop. Okay, but these are called statement pass statements. Since it doesn't have, you don't have to put parentheses. But whenever you have to put a parentheses, it means you're calling that thing. Okay, and you can call a function. Okay, so whenever you see something and then you put parentheses in front, it means it's a function or a method, and they are calling it. For now, just take functions and methods with the same thing. They are not the same actually, but you can see them as the same thing because most of the time they are used interchangeably. But when we get into OOP, I can now separate what a function is or a method. Okay, but for now, take functions and methods with the same thing. So once you see me put parentheses in front of any statement, it means that's a function. Okay, so we've talked about of course the print function. We talked about other functions. I think we talked about len. We talked about other methods like .append method. We talked about other methods like .sort. Okay, we've talked about functions like sorted. Sorted is a function, not a method. We've talked about other things. Okay, so I think it's also important to talk about another function that is critical, and that's the input function. Well, the thing is, in data science, you rarely use the input function. But I think as someone that would say understands Python, it's a slap on your face to say you don't know what an input function does. Okay, so even if you won't be using it so much in data science applications, it's important for you to know what the input function does as a Python program. So of course, you type the input function, right? So right out of the gate, I'm going to run this function and see what's going to happen. So what's happening is giving me something to type, right? So that's what the input function does. It allows the user put in values, or it allows the user feed in values from the keyboard, right, to the program. Okay. We know that a print function would print value from the program to the user. Okay, but the input functions allow the user to type data into the program. Okay, so that was the input function. So if I just print something like, if I just type something like David, it's going to give me David House. Okay, but this is not really nice. I mean, what's the point of doing this? Most of the time, we use the info or the data from the user for something. Okay, for instance, if I want to take my user's name and print something like "Good morning, David," I can do that with the input function. So what I'll do is that, of course, I'll call my input function, right? So the thing is, when you're putting your input function, the last time, what did it do is it just gave me a blank space to type. It's always good for you to give the user a prompt, tell the user what to do, guide the user on what to do, okay? So it's good practice to always put in a prompt. And that's the first argument to pass when you call the input function. So I'm going to put the prompts there. The prompts, of course, will be in string because you want to explain what the user has to do. Okay, so I'll just say something like, where's my, okay. Enter, please enter a name or something like that. So please enter your name. Okay. And I put the space bar. Okay, so now this time, when I run this function, it does give me that empty, space. It will print, please enter your name, then give me the empty space. So if you don't believe me, I'm going to run it right now. So I run that, look at it now. It tells me, please enter your name. So you're guiding the user on what you expect him to type. So now I can type David. Okay, and print David. Okay, now, but I said, let's try to print, let's run a code that will take an input from the user and then print something like good evening, David, or good morning, David. Okay, so if I want to do that, it means that I have to store this input function in a variable. I've been using name too much, but I think most of the things we're dealing with are names. I'm also going to use names again. Please don't get too comfortable with names. You can use anything to store your variable. Okay, so I can call this X, but I like using descriptive stuff. That's why I'm using name, in fact. Okay, so I'm going to use name again. So let me now put my input function right now in this variable name. So please enter your name. Okay, so it means that this David will be stored in name. Okay, or whatever I put in this input function would be stored in name. Okay, I hope that makes sense. Okay, so should I have done this? Okay, so whatever whatever the user inputs in name, inputs in this input function will be stored in name. So I can now print something like, okay, print good morning plus. Now it's with the print statements you can or let me know it's plus, you can use comma. Okay, so I can print more than one stuff at a time and you separate each of those objects with a comma. All right, so I can now add print name as well. So this statement just means print good morning, comma, print name as well. Okay, so now let me run this. So now let me use another name. Let me use Jane. So you can see good morning, Jane. So it's just a fancy way. It's a good way of course, getting data from the user. And then if you want to play around with that data, it's good. So, of course, maybe you're working with stuff like a mobile app or something. Well, of course, users to type in your username and password, and then you check if the username and password is correct, whatever you're doing, you can do that. How can you build a fantastic program with that? All right, we can do that. So let's do something like that. I think it'll be fun. So let's try to build let's try to build a program that would check if a password is equal to the password used. Let me assume that the password, its ATM password is 1234. Okay, and then I want this user, and I want to write a program to check if of course the password it enters is equals to or is the same thing as the password they have saved in our database. Okay, so already you have saved this password as 1234 in our database. So now it wants to of course check his password. Okay, so let me now type user input. Okay, is equals to, now I'm going to use the input function because I need him to type a password. So I'm going to type, please enter your PIN. Let me use PIN so it doesn't okay, so please enter your PIN. So it means that this user, of course, put a PIN there. But let me use a 4-digit PIN so it's more descriptive. So a 4-digit PIN. Okay. So it means that this user, of course, will enter his PIN. So now I'm going to check if this user's input is equal to the password they have saved before. All right. So you can guess already what we're going to use, an if statement. And that's one thing about Python. You can be read like plain English. It's not like Java where you first see system.out print line, or you first see some funny stuff like void, main, class, all those funny things. Because I started with Python. I started with Java, pardon, and then it was crazy. So the crazy thing to do, but Python you can read it like plain English. But Java is actually very good. It exposes you to all the important things you need to know already. But in Python, at least, you can still do the powerful things, but you don't have to learn all the crazy stuff at first. Okay. So I'm going to use an if statement to check, all right, if this guy is right. So let me use an if statement. So I'll say if user, okay, inputs is equals to, now mind you, since I'm comparing, I use the double equals to sign. So if user input is equals to password, okay, then I can say print the entered the correct password. Okay, but if it's not, so I can put an else statement. I can put an else statement and say print you entered the wrong password. Okay. So if I run this right now, I tell you, oh, enter a 4-digit and I put gibberish. Boom, you enter the wrong password. Or let's run it again, and then 1, 2, 3, 4. Boom, you enter the correct password. Okay, so that's just a very simple program. We can add more functionality to this by putting this in a loop so that it keeps on running. Okay, it keeps on running until he enters the right password, or you can even give a specific time. So maybe we want it to just run 3 times. we can add a counter to count how many times it's running, and then you do what you have to do. Okay, so we can actually add that. And even though I didn't plan this, let's try to see if we can do that. So let's say we want to make sure this thing keeps on running and he has 3 trials to actually enter his right password. And if after 3 trials he doesn't enter his right password, we can break out of the loop, and then he doesn't it's going to be locked out, something like that. Okay, so the first thing we need to do is actually to put a counter variable. So it's be like a variable that will check how many times he has tried. Okay, so let's call that counter. Let's say let's just say he has 3 trials, so he can count 3 times. Okay, so what can we do? We can say while loop, right? So we can say while counter is less than 3. Okay, sorry, counter will be 0 at first. So counter will definitely be less than will be 0. So at first he has not tried anything, so counter will be 0. Okay, but we want to make sure that it doesn't count more than 3 times. So you can say while counter, okay, is less than 3, then we can put an indentation, right? I put an indentation like this. Okay, so while counter is less than 3. Now, if user inputs is equals to, okay, now I'm sorry, I'm going to be doing a lot of changing because I need to put this user input inside my for loop. It's very important so that the counter will take note of when I have entered my PIN. So I need to cut this out. Okay, cut it out and put it here. So while counter is less than 3, then okay, now input your PIN. So after he has input his PIN, I must increase my counter by 1. So how do I increase my counter by 1? I just say counter is equals to counter plus 1. Okay? Okay, sorry, this should also be indented. That's a big mistake. Okay, this should also be indented. Okay, so I think I'm done with this program. So let me go over it once again. So first of all, of course, he has his PIN or his password, which is this. Right now, I have a counter to check how many times he has counted. Okay, so first counter will be 0, counter will be 1, and counter will be 2. Okay, so now look at this. I said while counter is less than 3, then input your password. Okay, so input a password. So he can now input his password. Now, once he has input his password, before even checking whether it is correct or right, is right or wrong, first increase your counter by 1, which is what I did on the slide here. So without even checking whether it's wrong or right, the first thing you must do is to increase your counter. So you've made 1 try already, so counter must increase. Okay, so now when counter has increased, I can now check. So now let's check. So if the user input, right, is equal to the password, print you entered your correct password. Okay. So else print you entered a wrong password. Now, one interesting thing you can do is that, okay, let me run this before I go further so I don't add up a lot of things together at once. But let me run this. So I tell you, please enter a wrong password. And then it enters, let me enter something wrong. It tells me enter a wrong password. In fact, so I can see that it's telling me again to enter another password. So I can do another nonsense. Okay, it's telling me enter a wrong password. It's telling me to do it again. I can do another rubbish. And then you can see the loop stop, enter the wrong password. Okay, so one thing I can do is that after this third trial, after you have broken out of the loop without entering the right password, one thing, okay, let me run this code again now with entering the right password. So you see what's going to happen. I entered the right password. I entered the right password, but it's telling me to do it again. Okay, so that's one thing. When you're writing code, it's always good for you to test because you may not know what's wrong with the code until you start testing it and seeing how it is in real life situation. So one may have thought he has written a fantastic code, but this code is not really fantastic because now he has entered the correct password, but the code is still telling me to what? Enter that 4-digit PIN. What nonsense is this? Imagine your ATM is doing this to you. In fact, I'm sure you'll be going to fire for the bank attendants or whoever is on the counter there. So the thing is, it means that whenever this is correct, whenever I've entered the correct password, I should break out of the loop. Okay, I should break out of the loop. And how do I do that? I just put a simple break statement like so. Okay, so it means that, okay, guys, if I've entered the right password, I break out of this loop. Okay, so okay, I have to finish up this program. So let me write some rubbish. Okay, so now let me now run this again. So I run the right one. You can see. So I entered the right password now, and it told me, let's just say it told me, but it told me you entered the correct password. Okay, and then that's all. It's a loop, the loop has ended. So sometimes it's important to use these break statements. Okay, it's important to use this break. The other statements you can use like pass, continue. I'll get to that when I need to. So I don't want to overflow with a lot of stuff. So I'll get to all those stuff when I need to. Okay, so one thing we can also do is just to make this thing interesting, and is that if this loop runs successfully or runs completely without entering the right password, we can tell him, sorry, bro, maybe your account is blocked or something like that. So if you try this thing 3 times and you enter your own password, your account will be blocked. So one thing is that this else block, right? This while blocking, right, can also take an else statement. And that statement only comes up when the while loop has run completely, okay, and then the condition is not even fulfilled. Okay, so I can come to this while loop here and put else prints your account, okay, your account has been blocked for 3 wrong tries. Okay, so I can do this just to make it a little bit more interesting. Okay, so I run this now, enter rubbish, enter rubbish, enter rubbish, boom. Your account has been blocked for 3 wrong trials. Okay, so it's just one of those things you can play around with, and then I think you have fun. So yeah, so I think this is also a good way to explain how to use while loop with if statements and all those conditions and all. So you can do a lot of fun stuff with this. Okay, all right. So let me also use a for loop with an if statement. So say for instance, I want to print even numbers from 0 to 100. Okay, so I want to print a list of even numbers. Now, if I want to print a list of even numbers, of course, first things first, I have to create an empty list. Okay, so let me just call it even numbers for now. Okay, even though it's nothing, I'm going to populate it with even numbers. So even numbers is an empty list. Of course, to create an empty list, you just create an empty square bracket like so. Okay. The next thing is to use a for loop to iterate over numbers from 0 to 100. Now, I said that the best way to iterate over numbers from 0 to 100 is to use the range function. Okay, so I will say for number, let me just call number, for number in range of 100. Okay, so what this does is that it just gives me numbers from 0, 1, 2, 3 to 99. So I call this 101. Okay, so it gets to 100. Okay, great. So I put a column. So this thing now goes over numbers from, like I said, 0 to 100. So at the first loop, this number will be equals to 1, equals to 0. Okay. The second instance, this number will be equals to 1. The third instance or the third loop, this number will be equals to 2. The fourth loop, this number will be equals to 3, and it goes on until it gets to 100. So what I want to check, I want to check if the number is even. Now, what's a property of an even number? An even number, if you divide by 0, if you divide by 2, it's have 0 as a remainder, right? So I can use the floor operation to do this. Okay, so I can do if, okay, if number 2, okay, is equals to, now take note again, I'm using double equals to sign because I'm not assigning this number to this value, okay? I'm comparing. That's also one important thing, but so I'm comparing, I'm not assigning. There's a difference between assignment and comparison. So when you have 2 equals to sign, you're comparing. Okay, so if number floor 2 is equals to, I won't say it's equals to, but it's equivalent to 0, or is the same thing as 0. Yeah, that's a better way to put it. So if this thing is 0, okay, then I can now say, okay, add that number to this my empty list of even numbers. Okay, so I'll say add this number to this guy. Okay, so I can now say even numbers. Okay, even numbers dot. Now, let me ask you guys in the comment section, because I think you guys have been enjoying yourself. So what function do I use to add a number to a list? I've mentioned a couple of functions for adding, for playing around with lists. I think I mentioned append, I mentioned sort, I mentioned extend, I mentioned delete, pop, all those stuff. So what function or what method is a method? What method do I use to add a number to a list? Can I get answers in the comment section? Okay, people are saying append. Okay, I think that's correct. Okay, so you use the append method. Okay, so I use dot append. And I'm happy you guys got that, because it means you're following. So I'm just going to do even numbers dot append what? What am I appending? I'm appending this number. Okay, so append this number. The last thing I can do is come out of this loop, because after the end of this loop, these numbers, this even number list will be populated with every number that has a modulus or a floor division of 0. So I can now say, okay, again, print even numbers. Let's go over this code again. Even numbers there. Okay, for number in range of that even number. Or should it be percentage? I think I'm mixing these two things up. God. Oh God. This should have been a percentage sign. Should be a modulus, not a floor division. So a floor division actually returns it returns the quotient, right? Why this modulus returns the remainder. Right. Making some very funny mistakes. Okay, so yeah, that was that for that. I just wanted to let's talk about it. Okay. Yeah. So I wanted to talk about functions, right? But before I talk about functions, let me talk about formatted strings, because I personally use formatted strings a lot. Okay. Formatted strings is just a way of writing printing strings and integers on the same line. For instance, if I wanted to print, the way I printed this good morning name, I can use formatted strings to do that. I know this may be confusing for now, but maybe if you do it over time, you get it. So let me do something like, okay, let me do something like a first name. Okay, call it input. Okay, enter your first name. Okay, I can do last name is equals to, I'm sorry, it's my equal to sign. Okay, input, enter your last name. Okay, so if I want to print a message like the surname of David is Olatunji, for instance. Okay, so the surname of David is Olatunji. So I want to print something like the surname of his first name is his surname. If I want to do that using commas, I'll do something like the surname of, then I put a comma, I put first name, I put a comma, open another, I open another, open apostrophe like this. I put is, open another comma, and I put his last name. Okay, so if I run this, first name is David, second name is Olatunji, and then it prints that statement for me. But this is not a good way of doing stuff, because there are times when it gets very complicated, and then if you use a lot of commas and apostrophes and all, you will get confused. So one other way of doing this same thing is to use what we call F strings or formatted strings. So I'm going to come back out, and then I'm going to try to use F strings. Okay, just give me a moment. Okay, so let me use f strings now. So to use f strings, I'm just going to do print, or instead of opening an apostrophe straight away, I'm going to first type f and open my apostrophe like this. So inside this apostrophe, you can see this like a string stuff. So I can put a lot of strings here. Okay, so that's the idea. Also, you put the strings you want to put. Okay, so I put something like the surname of. Now at this point, I need to put my variable. Okay, so to put my variable, I put my variable what we call a placeholder, and that placeholder is denoted with a curly braces like this. So I open a placeholder inside my string. Okay, that's important. So I open a placeholder inside my string. So now my first placeholder will be f name. Okay, surname of f name is, now I need to put another variable. So I open another placeholder like so, and I put last name. So if I print this, it's going to do the same thing the last statement did. So I run that, I put something like div bubble, something like that. Okay, so you saw him of Davis bubble, something like that. As you can see, this is also printed. So this is a clean way or a cleaner way of doing exactly what I did up here. Okay, but it's important to put this F before you open your apostrophe. That's why it's called formatted string or F string. If I take this out and I do the same thing, it's definitely going to give me an error. So I'm going to follow this one. Well, like I said again, in Jupyter Notebook, it stores what you've done before already in its memory. So if I restart it, okay, so now it prints the surname of F name is L name. What is happening is seeing these guys as strings as well, not as placeholders. That is exactly what's happening. So normally you should see these guys as placeholders where I can impute, variables. So normally it should give me something like the surname of Ege is NDF, right? But because I didn't put F here, it's saying all these guys are strings. Okay, so I need to put F to make them placeholders. So you can see now they are no longer in red fonts. They are now in black, meaning they are variables or they are placeholders. So I run that again and put some gibberish. You can see it prints it the way I want it to print. Okay, so yeah, that's it. So let's move very fast because a lot of things to talk about, trust me. Okay, so let's get into functions. Now I've been mentioning call this function, call print function, call that. And that's the thing about Python is it's an open source language. People can code stuff, people can do stuff, and then you can just use a function, a chunk of your code. So what is a function? A function is just basically a chunk of code that can do a particular task. Okay, so if, for instance, I'm writing a code where I'll be repeating a particular task, maybe I'm writing a code where I want some things to be done, and I just want that to be grouped, okay, together in one code, then I can create a function for it instead of repeating myself over and over again in different places. Okay? So that's what the function does. Basically used to remove repetitions in code. So, and of course, kind of classify your codes so that there'll be needs, and then you know what this chunk of code is doing. And then once you call that function, it does that thing right out of the gate. Okay, so to define a function in Python, we use the def keyword. Okay, so we call the def keyword. Now, after you call the def keyword and space, we need to define, or you need to call your function a name. You get by convention, you use small letters and separate. If you have more than one word, separate them with separate them with underscore. Okay, so let's say you want to create a function that adds numbers. So I can call that function add, okay, and open parentheses like so. Now inside these parentheses, you pass what we call a parameters. You call them parameters. Okay, so what's a parameter? A parameter is just the variables that you're needing in your function. Okay, so take for instance, I want to add two numbers. The parameters I'll need is my first number and my second number. Is that right? So I'll need my first number and my second number. So in this case, of course, this is not the point where I put in the number exactly. I can just call that number some variables. So I can say, let the two numbers be A and B for now. Okay. Then after doing that, you put a colon like so, and of course it's indented. It means that whatever code I'm now writing underneath this is is inside this function. Okay, so let's just say we want to explain. It's always good practice to make your code readable. So the way we do it is to put multi-line comments. I've explained already before. So it uses multi-line comments to just explain what this function is doing. So I can say this function adds two numbers together. So now let's do the real thing. So so we can do something like a plus, that's my addition sign, okay, plus b, okay, and then we can say something like print. Okay, let me call that summation. So we can. Okay, there's no point putting a lot of variables. Let me just do something like print a plus b. Okay, it's as simple as that. So if I run this, nothing will happen. That's interesting in our functions. Is when you define a function and you run it, nothing happens at that point because you're just creating the function. Okay, but the written happens when you call the function. Okay, so how do I call the function? I just use the same name I used. So I use add as my function name. So I call the function with a parenthesis like this. Now inside this parenthesis, you pass in arguments. Now remember when I was creating the function, I called them parameters. These are just conventions. Anyway, many times people confuse parameters with arguments. But in the real sense, arguments are when you are using the function or executing the function, and they are called parameters when you are creating the function. Okay, so now I need to pass in these two guys as arguments. So is that this, of course, like you can see, if I'm adding a and b, it means my a should be the first number and my b will be a second number. So let's say I want to add 5 plus 2. Okay, so I must put 5 as my first argument, comma, and then b will be my second argument, in this case 2. So I run that, you can see printed 7. Okay, but really, it's not actually a good thing to use print statements when you're dealing with functions. What we use is the return statements. The return statement is just like the print statement, but it's not like it's just like the print statement. But there are times when you may not want it to print it in the open. You just want it to be kept there. So whenever that function happens, this whatever you put after the return statement will be kept. Will be returned, it will be kept somewhere. It may not be printed. Okay, so I run this right now. First printed is 7, but in cases where it's not something that can be printed, it will just be stored somewhere. Okay, it's just be stored somewhere, and you can use that result for your next line of code. Okay, so that's the idea about functions. We're using a lot of functions going in this class, so it's important for us to talk about it. Let's talk about something that's also very critical, and that's the Lambda function. Now, a Lambda function operates like a normal function, just that in the Lambda function, you do not have a name. Okay, you do not have a name. Okay, so of course, in this particular function I created, I call the name add. But if I'm creating a Lambda function, it's just like an anonymous function. So the function doesn't really have a name. It's just a function. You give it the parameters you need it to have, and then you tell it what the function should do. Okay, that's just the idea of a Lambda function. It's a one-line function. It's a one-line function. So everything happens in a line. In this case, as I can say, I wrote this, I wrote this, and then it will take 10 lines, 15 lines. But the Lambda function are those short functions that you need to do something very quickly. For instance, if I'm creating a function that is adding two numbers, I don't have to create it like this. I can use a Lambda function, so it's something that's very easy and then can be done in one line. So how do I create a Lambda function? I use a Lambda keyword. Okay? So Lambda keyword, I can see it turns to green. So the next thing I'll need to add my parameters. So it's actually the next thing I want to define are my parameters. So what are the things that will be needed inside that function? So again, let's just say, or let's use X and Y this time. So let's say I'll need X and Y. Okay. So these are my two, or let me just say Z. Okay. So it looks legitimate. Okay. Nice. So now I'm defining 3 parameters in this function. Okay. So the next thing I can do, or the next thing that I have to do is to create, is to put a colon like so. Okay, so once I put a colon, I will now, the next thing I'll put on that same line, is now what the function should do. Let's say I want to add x and y and subtract z. So what I can do is x, okay, plus y minus z. Okay. So if I run that, of course, it has created a function as an object. That's what this is saying. Anytime you see something like this in square bracket like this, it means it's like an object. Okay, it's an object in Python. So I can now save this as a variable. Let me just save it as a variable. Let me say let me just call it addition. Let's call it add again. Okay. You can see it's a one-line function. So if I do something like add, I must pass in these 3 parameters I put. But now, remember they are called arguments once I'm calling it. So let me pass in 3 arguments. So let me say I want to add 5 with 4 and then subtract 9. Okay. So if I run this right now, it will print that result. So if I run that, you can see it gave me 0 because 5 plus 4 is 9. 9 minus 9 is 0. So these are 2 lambda functions. And again, this is something we use often as I'm talking about it. Okay. So before I go on, let me know if anybody has any question thus far. So does anybody have any question? Let's talk about list comprehensions. Okay. List comprehensions. We'll talk about regular expressions when we are doing something like NNTK, that's or we are doing NLP, sorry, that's natural language processing. So use NLTK library for that. We'll get to do that later on. But for now, let's discuss list comprehension because yeah, you'll be needing to in data science or when you get into pandas. Okay, so let's say I have a list of numbers. So let's say I have a list. Let me just call it X, even though I don't like calling my list X, but let me call it X this time. So it's a list of numbers, say 1, 3, 6, 7, 12, 45, 67, 11. Okay, so this is my list. Let's say I want to, I want to multiply, or I want to square every number in this list. How do I do it? I have to look over this list, then square each of this number, and append it to a list. Let me repeat myself. If I want to perform an operation on this list, for instance, say for instance, I want to square each number, what I'll do is that I'll create an empty list, then I'll look over these for these lists. Then once I have each number, I can now square each of that number, save it in something, in a variable, and then add that variable to this list. Okay, it sounds confusing, so let me do it. So if I want to, for instance, square this number, I have to create an empty list first. So let me put that list Y. This is not good practice for language list. So Y. Okay, so the next thing to do is to look over this list. So I'll do 4. Okay. For I in X. Okay. And this is why I say it's not good practice. But you can see now this is becoming very stupid. For I in X doesn't make any sense. What I'm doing is that okay, let me use for number in X to make some sense. Now, so I'm checking each of these number in these lists, and then I'm going to square it. So I can do squared numbers is equals to number squared. Okay, so what is happening is this: for a number in X, it means that the first time this number will be equal to 1. So I'll do number squared and I'll save that number as squared numbers. Then it goes to the next loop. Number is now equal to 3. Do number squared again, save it as squared numbers. The next loop, number will be equal to 6. Do 6 squared, save it as squared numbers. Okay. The last step, of course, is now to do something like, of course, my empty list. Then I'll append this squared numbers to my empty list. Okay. And then, of course, lastly, I can now print my once empty list, which of course will now be populated with square numbers. So if I print that, you can see it gives me the square numbers. So now where does list comprehension comes in? Now list comprehensions can be used to do all these things in a single line. All these things I did now, all these things, right? You can do everything in one line. In fact, if, for instance, I wanted to care about number, maybe I want to square only numbers. Okay, let me run this first, then I'll go to the next stage. Okay, so as you can see, this gave me the square of all numbers or all elements in this list, right? So now let me do the same thing with list comprehension. Okay, so I've defined my list already. Let me copy it again so it doesn't sound confusing. So that's my list. Now the next thing is to create a list that square all the numbers uh, in this X list. Okay, so what I do is that I use list comprehension. And how do I do list comprehension? Okay, just do open the under list like this, and then you tell this guy what exactly you want to do. So the first thing I want to do, or the thing I want to do, is the square of all these numbers, right? That's the thing I want to do. So I can use anything. Let me also use number, so I don't confuse. So I can say number squared. So I have a number squared like this. Okay. So this is what I want to do to this list. I want to do number squared straight. So the next question Python will ask you is, of course, what is number? Because number is not defined. All right. So how do I define my number? I'm going to now look over this list with a for loop. So I say for number in X. It's as simple as that. It's as simple as that. So again, it's just like what we used to do in maths. Okay, when you're writing an equation, you just write the equation first of all. You cannot define where X is equals to something, where Y is equals to something. That's the same thing you're doing here. So I'm just going to create this number, which is unknown, of course. First of all, is unknown. So just say number. What I want to do is a number. I want to square it. So this is like my formula part, and this is like my where something is equals to something. Okay. So first I do number squared. Then I will now loop over this list. So I'll say for number in is another keyword, right? Because I'm looping over this list. So I'll do for number in this list. So it's going to loop over this list and append this straight away. So if I run this nice and smooth, it's going to give me exactly what it gave me in this last one. So if I want to make it interesting, I can also call it Y. I also call it Y. Sorry. I can call it Y and I can print Y. So that's just to make it nice. So it's the same thing. Okay, so that's the essence of list comprehensions. And I think when you want to manipulate columns, all of those stuff, you're using list comprehensions for that. So as I was saying, you can also add your control flow inside this guy. So take for instance, if I wanted to square only the even numbers in this loop, for instance. So for all the odd numbers, I'm going to leave it as it is. So I only want to square even numbers, right? So what can I do? Of course, I'll put an if statement. I'll say if number, so I have to put that if statement before I append. Okay, before I square it. So if number divided by 2, okay, is, that's my equal to sign up, let me say it, is equal to 0. Okay, then I can indent this guy like this. Okay, so now what this does is that first things first, it check if this guy is an even number. If it's an even number, it squares it. If it's of course not an even number, I leave it that way. So let's run our code and see how it works. Okay, so you can see that it only takes numbers that are even, right? Sorry, it takes only numbers that are even because this is like an if statement. So it takes only the numbers that are even. So if number is even, then you can square. If not, don't append it, don't do anything. So the same thing I can also do here. The same thing I can do here. And how do I do that? I will just add an if statement to the end of this list here. So I can say for number in X, if number, the same thing I did here, but everything will still be in that line. Okay. So if number plus 2 is equal to 0, and then if I run this, it gives me the same thing. As simple as that. So let me get questions. Does anybody have questions about these comprehensions? Does anybody have questions? I would like to talk about for today is actually importing Python models. Okay, so when you're working with data science, in fact, if anybody has checked any data science project, you always, the first things you see, import this from this and this, import that from this and this, import that, because really you're using a lot of, maybe third-party models, or they are called libraries or stuff like that. So in Python, you have to, not everything is in your code already. So your code doesn't have all functionalities yet. Okay, so there are times when, because it's an open source stuff, people do a lot of things on it, and then I can even create a code to do something, and then people can import that code, okay, using an import statement. So if I create another Python file, for instance, it's not because I'm not using VS Code, but if I'm using VS Code, I can create this guy right now. If I save it, if I save it to be a Py file, I can import this code into another code, and then it will be able to do this same thing that I did here, this addition that I did here. So the idea of import statement is just to take out what people have done before and you reuse that code. Okay, so you'll be importing a lot of stuff. You'll be importing stuff from NumPy, from pandas, from everything. So, but first off, let me just talk about maybe the imports maths, or the imports the import math statements. So of course I can import math like so. Can import maths like so, and then with that I can do something like, maybe I want to create if I want to create maybe if I want to know many things. So one thing you can do to know the methods in this thing is just after putting your math dots, you press the tab and tells you all the things you can do with this. So let's just say I want to create the course of number, let's say 30. If I print it out, it gives me that in the course of 30. Remember, this is the radian actually, not in degrees. Okay, so yeah, that's that. So you can import stuff and then play around with stuff. So I can also do something like maths.py. Okay, so I can do maths.py. If I run this, okay, so pi is an attribute, I guess. Yeah, pi is an attribute, not a function. Okay, so well, I was going to talk about attribute and functions when we get into OOP. All right, and then well, we have not gotten to that yet. But the thing is, when you talk about objects, okay, maybe I should just talk about OOP right now because I have to explain OOP before going into attributes and all of those stuff. So let's talk about object-oriented programming. Now, the thing is, I mentioned the other time that everything in Python is an object, but nobody really asked me what exactly an object. But I don't know how to put it because really an object is an object. We are humans are objects. When we are doing physics, they told us everything is a body. So any small thing, a body moves from, a body did that, a body. So the same thing in Python, everything is an object. And actually you can define an object as something that has a property and something that has a function. Okay, so an object can do something, an object has something, and it's just the same thing as anything you can think about. For instance, a cup has an handle, and the cup is used to drink water. Okay, so everything is an object based on what it has, its properties, and then what it can do. Okay, so the same thing for Python. Python, everything is an object, and everything can have a property, and then everything can do something. So yeah, I use this cos object and this cos function to turn 30 to the cosine of 30. While here, I'm just trying to check the property called pi. It's just like a property. A pi is not doing anything. Okay, a pi is not. I'm not like I'm finding the pi of 15. Pi is just something. Okay, so I'm trying to check what pi is. So the same thing for list. I think I didn't talk about it. Okay, I think that's when we get to NumPy. You can use the shape attribute to check what is the number of rows, number of column in this data sets. Okay, so you can use the shape attributes and all of those stuff. So that's the idea of this. Okay, so I'm contemplating whether to go into OP right now, but okay. So the thing is, you can also create your object in Python, and that's what object-oriented programming allows you to do. So in this case, say for instance, I want to create thinking of what I want to create a person, okay? I want to create a car, and then the car will have, of course, a car is an object. The car maybe will have a number of tires, the kind of diesel, the kind of fuel it uses, its mileage, and all of those stuff. Okay, so what can happen is I'll use the keyword class. Okay, the next thing I'll do is to give this class a name. Now, when you're calling the word class, it means you're trying to create an object. That's what's the meaning. Okay, you are trying to create an object. That's what this class does. So let's call of course this is class. So I'm just going to call it, what can I even call it? Okay, let's just call it car. Okay, let's call it car. Now the next thing to do is to of course is to give these cars some property or some functions. Okay, so you do that by defining a def function, or you create a function inside the class. Okay, so I'm just going to make it as simple as possible. So let me say I want to create a class that will make this car move, or that will print this car is moving. So I can do something like def move. Okay, I hope this doesn't get confusing. But when you're creating a function, you're creating a class yourself or an object yourself, the first arguments that you must put, of course, I told you that when you're creating a class, you must put an argument. So yeah, my arguments was A and B, or my parameters were A and B. So yeah, the first argument you must put is what we call the self arguments. And after that, you can put any other thing. But for now, I don't care about any other thing. I just want to print something like this car is moving. Okay, so I'll print something like this car is moving. Okay, so I can also print something like a stop function. So of course, take self. Now the thing is, anytime you're creating an object your own, and you create a function inside of it, you must put in this self. You must put in this self. Okay, so let's just print something like this car is stopped. This car is stopped. Okay, so well, let me give it some properties. So I can say that dev let's just say, what can I call it? What can I name it? I'm confused right now as to what I name. I didn't plan on talking about this, but okay, for now, let's just end it here. And then if I want to, for instance, if I run this, it's going to run without problems. And then when you are, okay, the thing is, when you now want to use a class, you can't just use that class on your own. You have to create a copy. They call it instantiate. Okay, so you have to instantiate a method of that class. So let me say my first class, I want to create a car, real car now. This is like an architecture of a car. But when I'm instantiating, I'm creating the car for real. Okay, so let's say my first car will now be, let me just call it car 1. Okay, and then I must instantiate this car like so. Sorry if I'm confusing you, but this is how you just have to do it. So my car 1 will be something like this. So now I've created like an object, okay, called car 1. I've created an instance of this class called car 1. Okay, so if I want this car to move right now, I can now call this method. Okay, this move method. So if I do something like car1.move, okay, it will print something like this car is moving. And let's try it out. You can see that it prints this car is moving. So I put something like car1 dot stop. it's going to create this car is stopped. Okay, so I can create other copies of the cars. I can create another car 2, car 2, and then I'll call it another instance of the car, and I can do something like car 2 dot stop, stuff like that, and then it's just sorry, okay, car 2, sorry. Okay, so it just keeps on doing all of the stuff. So but I really don't like this application, and I'm trying to look for another thing we can create. Okay, let me create another class called automobile, because I want to make it as practical as possible. So let me create a class called automobile. Okay, by convention, when you're creating a class, you start with a capital letter. But when you're creating a function, you start with small letter. When you're creating a class, it's by convention, you start with capital letter. So I use, let's call it automobile. Okay. Okay, so let's call it let's define different properties of the automobile. So let's say dev properties. Okay, of course, let's call it self. Now the car, let's say the car will have some color. Okay, different automobile will have different color. It will have something like the kind of fuel used. So let's put that, the kind of fuel used, the mileage, what else will separate the car from another thing. Well, I wanted to put number of tires, but every car will have the same number of tires. Okay, so these are like the properties of the car. Okay, so how do I define each of those properties? What I do is I call this self dots. Okay, color is equals to color. What am I doing right now? What I'm doing here is that I'm pointing every of these features to this car, to these properties here. It means that whenever I call color will be assigned to this property here. Whenever I call for, it will assign to this property here. When I call mileage, it will assign to this property here. So self is just like a default argument that is used to point the other arguments of where they are going to. Okay, in this case, they are going into this properties function, and that's why a def, a self parameter is compulsory. Whenever you're defining a class on your own, or you're defining an object on your own, you must define you must add this self argument. Okay, so let's go on and just point the others to this properties class properties. So I do self dot fuel is equals to fuel. I do mileage dot self dot mileage, sorry, I'm making a mistake. Self dot mileage is equals to mileage. Okay, so well, I can run this nice and smooth, and I can create different objects of that automobile. So let me say Adiola, for instance, has 3 cars. Okay, one is red color, uses diesel. Maybe it just bought it. It has like 200k mileage. So I can create something like, maybe it's a Benz car. So let me just call it Benz. In fact, I can even put a name to just show the name of the car. So that's another property I can put. I can put name. So let me call that self.name is equals to, of course, name. So let me start. Let me say, okay, our first car 1, okay, would have, of course, I have to instantiate this guy. So I have to put something like car. Of course, sorry, I didn't use car this time. I use automobile. Right? So instantiate automobile like so. So once I instantiate automobile, now I have to pass in the different properties that I define. So I can say something like car 1 dot properties. So now remember that when I created this function, I called self, I called name, I called color, I called mileage, I called fuel. Okay, but I said that this self is just like pointing the others to these properties. So I really don't have to define self here when I'm calling this function or this method. What I do is I just start from this second parameter, which is name. So let's just say the name of this car is BMW. Yeah, and then it's black color. Okay, and then I can say it uses diesel. It uses diesel and it has a mileage of 20. Okay, that's it. So if I run this, statistics of 5 we're given. Coming. Statistics 4 argument of 5 we're given. 1, 2, 3, 4. Yeah, this should one. What's going on? I'm going, guys. Let's give a moment. Let me check this code. Save the names. I don't put self. What's going on? This shouldn't work. I should have put 5. I should have put name, color, diesel, mileage. Why? Why? Name was not true. There's a mistake somewhere. It's starting from color, not name, which is very confusing. Oh, maybe I didn't run this again. That's the mistake. God, I was wondering what's going on. The thing is, when I created this class, I didn't add this name at first. Okay, so I came here and started adding, all of those stuff. So I didn't run it again. That's the mistake I made. So I should go back and add my mileage. So let me call it 20 and then run this again. Okay, so yes, now it goes. Okay, so sorry about that. Sometimes when you're working, when you update any cell, it's good for you to run it again. If not, it will give you errors. I was a little bit confused as to what was going on. So that's the thing. Yeah. So so that's that. So if I now want to check maybe the color property, I can do something like can name.name, for instance. It gives me the name BMW. Can name.color. It gives me the color, as you can see, and all of the stuff. So if I say, for instance, I want to print something like print again, not like this car name is, all of those. I have to put an F string. That's a mistake. So all of those F string stuff I talked about. So I put self.name. It as it is red or whatever it is. Create this. So I put something like self.color in color. Okay. It has gone. Okay, actually, it has gone self.mileage mouse. I can split this. Okay, no, I can't. I must use. That's my Ford. Okay. Okay, it has gone dash mouse, and it uses let's say petrol. It uses petrol. So it has been served at petrol. Don't forget to put the self. Self is just like you're pointing it to where you should check its values from. So let me run this again. So if I run this right now, you're going to see what's going to print out. So error That's not triple petrol. Good. Self.fuel. Come on now. Okay, yeah. So you can see this car name is BMW. It is black in color. It has 20 miles and all. That's because I added all of these properties here. So I can create another instance of the class or another copy of this class. And I can call that car2. So let's say she has another Benz. So of course I have to instantiate automobile first off. And then I say car2 dot properties again. But this time it's now a Benz. The Benz is red in color. Red is red in color. Benz uses fuel or uses petrol. And Benz it's a quite old Benz, so it has gone like 1,000 K and 1,000 miles, whatever. So if I run this right now, you're going to see that this is like a first instance of the class car1, okay, or an object of the class. This is another object again, or another instance of the class car2. Okay, but it was important to, I know this can be difficult or a little bit complicated for all of us to take at once, but trust me, it's a very important concept in programming. And in fact, we use we have to instantiate a lot of classes. Like I said, I'm only touching the things that we'll find necessary or find useful going forward. And that's why, even though I know that, yes, this may be a little bit tough for us to take at once, it's important for us to talk about it. So, because we'll be instantiating a lot of class when we import, for instance, say for instance, I want to, what can I use? Okay, I want to do a robust scalar onto standard scalar, all those stuff. I want to standardize my data. So what I do is that from sklearn, okay, dot pre-processing, okay, imports, okay, imports robust scalar. Where's robust scalar? Okay, let me standard scalar. Okay. So, for instance, if I want to standardize my data, this is what I'm going to use. But this standard scalar I'm importing is like a class, just like this automobile I used. If I attempt to use this class like this, it will throw an error. After doing this, all good, I have to create an instance of that class. So I can do something like scalar is equals to scalar, standard scalar. Okay, so this line now is just what I did here. Okay, I created an instance of this class. Okay, so after I now create this instance, I can add something like scalar dot fits, transform, and all those stuff, and then that would create, or that will now do the standardization for me. But if I just try to do that without creating an instance of this class, it's giving me an error. Okay, so there are times when you'll be importing classes, not functions. Now, yeah, okay. Yeah, I imported a function. As you can see, it's a small letter m. Okay, so I imported a function and I can use the function straight out of the gates. But most time, or sometimes, you'll be importing a class. Okay, and when you're importing a class like this, you must first off instantiate it like this before you can use that class or use any method in that class. Okay, so yes, I needed to talk about this. It's very important. So even though I didn't really plan it, but it came up, and then I think it took a large chunk of our time, which is very good. I really don't regret it. So, well, I guess I'll be stopping here for tonight, and then by Monday we'll be going straight into NumPy and pandas. NumPy, I'm not going to waste time. Pandas, yes, and it may take some time. But once you have those two, or once you know how to use those two libraries, then I guess you've gotten into data science, because these are like the key libraries, especially for data wrangling and all. Then maybe you can now get to visualization with matplotlib and Seaborn, and then you can start using this library. This library is like one of the very key library when it comes to machine learning, sklearn. Okay, so we can now learn how to use sklearn to create very interesting stuff. And then once you master this, in fact, I saw a tweet recently. The person was like, if you want to learn machine learning, okay, learn mathematics or learn statistics. But if you want to earn, okay, if you want to earn cash from machine learning, learn sklearn, which I think is a very valid point. And yet many people say you need knowledge of math to do that. But bro, I'm not trying to create. It's good. It's good for you to be able to wrangle and play around all of these libraries. You must have understanding of math. But I'm not trying to create this library. Okay, I'm not trying to create a linear regression library from scratch. It's good to know how to do those things. Don't get me wrong, right? It's good to know how to do those things. But it's not like I want to do it. I just want to apply what has been done. Okay, and that's why really I wouldn't say maths is like a very key stuff in machine learning. It's good to know maths because it helps you understand what's going on under the hood, what's happening, what these guys are actually doing with all these maybe random forests, decision trees, all those funny SGBoost, all those libraries. So it helps you understand what those guys are actually doing under the hood. But you really don't need to know it per se to be able to use sklearn. Okay, and even when it comes to hyperparameters tuning, when you want to optimize or you want your model to perform better, you can use grid search or random search, and then it gives you what you want to give you what you want to give you without you knowing the mass of everything and then all the stuff. So hopefully by Monday we should do NumPy and pandas. By Tuesday we should do maybe matplotlib and start getting into sklearn so that we can use some time to do some projects for the end of the class. So I know there's a lot to take today, especially when we got into these classes and then all these self dots. But you really need to know it. So definitely we recorded this video and then it will be up on YouTube maybe tomorrow or the next, maybe tomorrow, so that you guys will be able to practice tomorrow before Monday. So it's a whole lot, and I'm sure you guys will have questions. So let me take some questions. All right, so if you've got questions, you can use the comment section. If you want to talk, raise your hands, and I'll allow you unmute your mic. Okay, I'm just saying this. Someone said, why did you add F? I told you it's called formatted strings or F strings. Okay, so when you are trying to add variables inside of a print statement, okay, you're trying to add a variable inside a print statement. So you want to create like a container, okay, of variables. You use, let me see if I use it here. You use these curly braces. Okay? So you use curly braces to store variables. These are variables now, not strings, remember. So you add this F to, if you don't add this F, Python will see it as a string. As you can see, it's now red. Okay, Python see everything as a string. When we put this F, Python now see them as variables. Okay, so that's what F string is about. Okay, someone said he wants to share a screen. I'm just saying this. Okay, why not? So you can share a screen. And okay, great. Okay. The one having problems with the thing is, I feel what happened is one of your codes. Okay, one of your code has maybe an infinite loop or something. So once a code is running, right? Once a code is running, it's the next one can't run until the first one you ran has run successfully. Okay, so what you do is that you start this kernel. So go and restart the kernel. Go straight up to kernel. Go to kernel. You can unmute your mic so you'll be able to talk now. Unmute your mic.
Okay.
Yeah, okay. So now restart kernel.
Okay.
Restart kernel, yeah. No, restart. Yeah.
Okay.
Just wait a minute. Check. If it tells you kernel ready. Does it say kernel ready? Yeah, good. Okay, great. Now go up. Scroll up. Now start again. Print the hello word. Print it.
Right.
Print it.
I'm not hearing.
Print it. Click on the cell. Click on the cell. No, click on the cell. Click on the cell. No, the first cell. This first cell. This hello word. Yeah, click on it. Now run and shift enter. Shift enter. Good. It ran. Next one, shift enter.
Okay.
Okay, now enter your PIN.
Okay.
No. You have to. Maybe that's the mistake you made. This is still running. You know this. I created an input. I called an input function. An input function, it needs you to type in some codes or need to type in some inputs. So you have to do all those before that code will stop running.
Okay, no problem. I will look into that.
So you have to type in something, and then we set it to 3. So you do it 3 times. So you type in something. You can do it now. Just type something.
Of course.
So this code will run. Okay, enter. Enter. You type in your wrong password. You decide to type in the right password, so it breaks up on the loop. Okay, type 1, 2, 3, 4 now. Type 1, 2, 3, 4. Okay, so you enter the correct password. So now you can see that this has turned to 2. It means that cell has run completely. So you can move on to the next cell and keep on running with shift enter. Okay? So shift enter.
Okay.
And then you continue like that. So I guess that's the mistake you made. Yeah. So this that also needs it also needs to input something. So you enter your first name, you enter something, you enter your last name, enter something, then it now prints that. So okay. Press enter. Press enter. Once you're done typing, you press enter.
Okay.
So you enter last. You type first name twice. That's why it's telling you to enter your first name. This one should have been changed to last, but it's okay. Not typing something new.
Okay.
Okay, so yeah, so that's it. So you can just keep on running your codes like that.
Of course, I will do it. Thanks, I really appreciate it.
Yeah, I'm kind of impressed that you'll be following me back to back. I mean, just you copied my notebook. Wow, that's quite impressive. But that's the way it should be anyway. The truth is, you learn by actually practicing. So you learn by making mistakes, by getting your errors, and by finding ways to solve those errors. Okay? So guys, make sure you practice. Okay, don't look at the screen and think you know it. That's the biggest mistake you ever make when it comes to programming. Watching videos or reading a blog article and thinking, you know that concept. That's a big mistake. You notice that just one line can mess you up. You wouldn't know what to type or whatever. It's just mess you up completely. So yeah, that's very important, guys. Very important, guys. So you can stop sharing your screen. Does anybody have any question?
Okay, thank you very much.
Let's take questions. I know we've talked about it. Nobody has question about self. I'm surprised though. You guys understand self. There's not something I didn't talk about, but I didn't want to go into it. But that's the init method. So when you are, let me share my screen again. Maybe I should talk about it just for a moment. Okay, so when you're creating your functions like this, there's one thing there's another function you can create, and that's called the init function. Okay, so you call it def and double underscore init like this, double underscore. Okay, so now of course, as always, the first thing you must put is yourself, and then you can now create stuff. But what does this init function do? The thing is, this init function runs automatically when you are creating or when you call in that function. Okay, so that's one thing about any function. So maybe you want to create a program where you want one function to run automatically for all things. Okay, it means that you must you must create an init function. So that init function will run automatically without you calling. You don't need to call. I have to call car1.properties for it to run. Okay, for it to run all of those stuff. But when I call my init function, I don't need to call something like car1.init before it runs. So let me just create a property, and then I'm going to call this one tires, because all cars have tires. So this is like a general rule of thumb to any object I'll be creating. So I can say something like, okay, I have to first create that argument here. So I can call it tires. Okay, so I can now say something like self.tiles is equals to 4. Okay, because really all cars have 4 tires, right? Okay, so self.tiles is equals to 4. Is that okay? So let me run this again. Okay, so well, I can run this now. Okay, what's going on? Why is this thing everyone scrolling? Voila. Okay. Okay. Just a minute. Okay, so as you can see, even though I was trying to create this guy, so it's telling me that I need these tires arguments. So where do I pass it? I pass it when I'm calling my class. Okay, not when I'm instantiating it. So I can do something like sorry, this is a big mistake. It's be tires here. Save the tires. Well, it goes to 4 because all tires actually are 4 tires. So I can come here right now. Let me put it as tires. And then I come here and put on like 4. Okay. What's this error again? It needs missing 1 positional argument. Really? Let me see what's going on here, because that happens. Okay, when you create this init, it runs automatically, right? So save the tires. What I can do is to create. Okay, maybe I'm mixing it up, guys. So well, okay, I'm coming. Let me put for you. Okay, yeah, that's my mistake. Well, why am I doing that?